Hello everyone. Welcome to the solution of LeetCode problem 144 named binary tree pre-order traversal. Before starting the discussion, I want to share something. This kind of problem basically belongs to the tree categories, and tree categories problem are the crucial for the technical interview. If you go in any company's technical interview round, you will find at least 2 or 3 tree related problem there. So you have to understand the tree related problem very well. Now let's discuss the problem. In this problem, we are given a binary tree and we have to return the pre-order traversal of its node's value. Now let's understand the pre-order traversal problem deeply by using this binary tree. Here we have a binary tree of root 1. It has 2 children, which is 2 and 3, and 2 also has 2 children, which is 4 and 5, and 3 also has 2 children, which is 6 and 7. And all of the 4 nodes, which is 4, 5, 6, and 7, are the leaf node because they don't have any other children. Now let's understand the binary tree pre-order traversal algorithm. At first, we have to visit the root and process it. After that, we have to traverse the left subtree, and after that, we have to traverse the right subtree as well. Now, let's analyze the output of the pre-order traversal algorithm by using this binary tree. At first, we have to visit root 1, which is the root, and we have to process it. So we will put 1 in the resulting vector. Now, according to the algorithm, we have to traverse the left subtree. So from 1, we have to visit 2. Now, 2 is also a root because it has 2 children, which is 4 and 5. So we have to process 2 and put the value of 2 into the vector as well. Now, from 2, we have to visit the left subtree again. So we will come to node 4. Now, node 4 does not have any other children, but it is also a root. So we have to process it as well. So we have to put the value of 4 into the resulting vector here. Now, from 4, we have to move to root 2 again, but 2 is also processed. Now, according to the algorithm, all the left part of root 2 is processed. So we have to now move on to the right subtree. So from 2, we will move to the root 5. Now, 5 is also a root which does not have any other children. So we have to process it. So we will put 5 here. Now, after processing, we have to go to root 2 again from 5. Now, all the right and left subtree of root 2 is processed and root 2 also processed. So we have to move on to the root 1. Now, all of the left part of root 1 is processed and root 1 is also processed. So now we have to move on to the right subtree of root 1. So from 1, we have to go 3. Now 3 is a root which has 2 children, which is 6 and 7. So according to the algorithm, we have to process it. So we will put 3 in the resulting vector. Now we are presented in node 3, which is the parent of node 6 and 7. So by considering it as a root, we have to visit the left subtree according to the algorithm. So from 3, we have to move on to the node 6. Now node 6 also a root, but it does not have any other children. So we have to process it and put the value of 6 into the resulting vector here. Now from 6, we have to move on to root 3 again. Now all of the left part of root 3 is visited and root 3 is also processed. So now according to the algorithm, we have to traverse the right subtree as well. So from 3, we have to visit node 7. Now the node 7 is also a root, but it does not have any other children. So according to the algorithm, we have to process it. So we have to put the value of 7 into the resulting vector here. Now from 7, we have to move on to the node 3 again, and all of the left and right subtree of node 3 is processed. So from node 3, we have to return the node 1 again, and all of the left and right subtree of node 1 is also processed. So it is the basic workflow of the binary tree preorder traversal algorithm. Now let's understand the solution. In this solution, we have to take a resulting vector to store the value presented in the nodes. And we are given a preorder traversal function which will return the vector. And we are given the root as a parameter. Now we have to check a condition. If any of the case root is null, we have to return an empty vector. After that, we have to insert the value presented in the root into the resulting vector. And after inserting the root value into the resulting vector, we have to recursively call the preorder traversal function into the left subtree. And after that, we have to again recursively call the preorder traversal function into the right subtree as well. And finally, we have to return the resulting vector. So this is the code. Now, let's understand the time and space complexity of this program. In the recursive approach, the time complexity of the preorder traversal is big O of n, where n is the number of nodes in the binary tree. This is because each node is visited exactly once, and the space complexity of the preorder traversal algorithm is also big O of n because of the functions call stack. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.